Hello, and nice to be with you about this webinar dedicated to SpecimINSIGHT, our processing software. Actually, I'm really thrilled because for this webinar, I will not be alone. You will see there will be a special guest, which is actually joining me. I'm going to interview Henri like part of our software team. Also, during this webinar, there will be a demonstration about our software, SpecimINSIGHT. Then you will be able to see the new features. And remember that if you have any question, do not hesitate actually to type it in the chat. At the end of the demonstration, me and Henri will be really happy to answer those questions. There will be also some polls, so we will be glad if you could answer to those. And remember that if you have any question, you can send an email at info@specim.com, and you can also visit our website, specim.com. About this webinar, so I am Mathieu Marmion, working as a lead application specialist at Specim. I've been working now for 14 years, soon, at Specim. And Specim, it is a world-leading manufacturer of hyperspectral imaging devices. So the company has been founded in 1995 and is a spin-off of VTT, which is a Finnish National Research Centers. Since over those 30 years of a journey, we actually delivered more than 10,000 devices all around the world. Since 2020, we are actually part also of Konica Minolta. We have local presences in different places all around the world. So we have our own offices in the United States, Spain, Germany, and China. And we also have our headquarters, which is located in Oulu, Finland. This is where I am located actually now. So this webinar, we're going to speak about SpecimINSIGHT, the new features, the coming release. And yes, please have a look to the video. It takes about 30 minutes. And then after that, we will come back. I am actually really delighted to be with my colleague Henri. So Henri, please, can you introduce yourself?
Hello, my name is Henri Hagberg. I'm the software lead at Specim and also one of the developers. I've been in the company for 14 years.
Yeah, actually I must say that Henri started the 1st of June and me the 15th. So we have been there about the same time, but you still own 2 weeks to me. So
yes,
you're still a bit longer.
Yes, I do.
So yes, you are part of the software team. Can you explain us a little bit like what is your software team, by the way? How many people do you have?
Yeah, so in total we are 8 people. There's 5 developers and 3 testers. And all of us work in all the software projects that we have, including Insight, which is the topic today.
Yeah, today we're going to speak about Insight, and actually there will be a demo after this interview. So Henri, can you give us a context actually for Insight? Can you put it like when it has been or how it has been created, and also give us a context, please.
Yeah, we used to have and still have the Lumo software family, and which is a data acquisition software family. And
yes, we have the SDK, we have Lumo Recorder, Lumo Scanner for data acquisition.
Yes,
and
we saw that there was a need for analysis tools and explorative tools and tools to make predictions to HSA data, and we started to build the software fully in-house that is able to do this kind of offline analysis, and also with the SpecimQ real-time analysis.
Yeah, so basically there is a context. We have identified there was a need for data analysis,
yes,
as you mentioned. And in order to complete this need, we decided then to have Insight. And as you say, when you use Insight, you can make a model which can then be used for real-time data processing. So can you explain a little bit more here?
Yeah, so in Insight, being an offline tool, you can load any kind of ENVI-based data, which all are other software tools like Lumo Recorder, Lumo Scanner, or the SpecimQ provide. And then you can train predictive quantitative or qualitative models, and you can test them within Insight with the offline tool, and then you can also apply them to real-time processing inside Cube.
So you can tune basically your quantitative or qualitative model within Insight. Once you're happy with your model, you tested the performance, and you can then load it to the Cube to have real-time data processing.
Yes.
That's great. Also, inside Insight, you have different levels. So you have the exploration part, you have the modeling part. So
yes. So we've separated Insight to different views that have a different purpose. We have the browse view, which purpose is the dataset management. So managing the datasets that been acquired with Lumo software or with Specim Cube. And we have the explore view, which is meant for explorative use. You have tools like PCA or spectral similarity tools or spectral calculator and other kinds of, and lots of different selection tools and plotting tools and for explorative use. And then we have the train view, which is meant for the creating the predictive models, whether they are quantitative or qualitative. And then there's also applications view, which is meant for the Specim Cube application installation and management. And then we, with the new release, upcoming release, we will add a new spectral library view.
Yes, actually, you touch a point which is really important. Now we're going to speak about the new release. Actually, that's the point of this webinar.
Yes.
So now we have the current release, which is 1.3. So then, starting in April, we're going to have the 1.4. So can you tell us why this 1.4 is actually a step ahead? So can you explain what are the main differences?
Yes. Well, first of all, as mentioned, the spectral libraries.
Yes.
So we've added the functionality to create your own libraries or load pre-existing libraries. Those are also Envy-based formats. And we also have a proprietary format as well, but Envy-based formats are supported.
Are we going to provide libraries, or the user will be their library?
We haven't decided that yet. Currently, we are not going to provide, but that's still, that decision hasn't been made yet. But if we so desire, we can provide also libraries. And maybe in the future, we can provide more libraries, even if we don't provide it at this release.
But that's a really important step, because the library allows the user, for example, if they are in the plastic industry, like sorting plastics, or if they are in the geological industry, there is a possibility like this to use existing library, for example, from the USGS, or you can build your own. And in that respect, you can apply it to different data sets. So that's really a step forward for different type of applications.
Yes, and so you can manage them, you can create them, modify them, load them, and then you can also use them in our different views, being explore and train. So you can use the spectral library Spectrum in the explorative usage and also in the predictive usage. So you can apply models that are just solely based on the spectral library Spectros and run them in Cube.
Actually, it's part of the demonstration. Part of the demonstration, we show how to apply those libraries, how to build them, so that's a good point. So the library is one new feature.
Yes.
Can you give us more?
Yeah, we've focused on the user experience. As we all know, hyperspectral imaging can be quite complex, and we try to make simple tools for complex problems. So we've added, for example, the manual. Manual is part of the software, so
That's a great add-on.
You can open the manual straight from the software. And also we've added these tooltips and hints for the user in different places of the software that explain shortly what the functionality is. Of course, manual has the longer explanation, but if you're wondering what is this part and why should I use it, there are now new tips on what are certain things in the software.
Yes, the user can see every now and then those eye icons.
Yes.
And so basically by clicking on those, there is a possibility to get some hints, as you said.
Yes, and also another functionality is the dataset preprocessing improvements.
Okay.
So previously we had the preprocessing only applied to the spectral plot, So you could inspect the pre-processing effects on the selections that you had, whether they were area selections or single point selections. Now you can also apply the pre-processing effects over the data set as a layer.
Because that's great, because we can see directly on the image the effect like this of the pre-processing.
Yes.
So you can see if it improves the sorting or not
Yes.
of your object.
You can see if your objects are more distinguishable after the pre-processing effects. And you can do this interactively. So if you change the order of the preprocessors, if you add new ones, or if you change any of the parameters of a preprocessor, it'll apply instantly. Of course, depending on the size of the data sets. For larger data sets, it's going to be a progress bar that shows the result when it's finished. But for a regular size data sets, it should be rather instant.
Okay. So we had the spectral library, we had the manual with the user interface. There is also the preprocessor. So those, I would say, are the main in terms of like usability of the software.
Yes.
But I heard as well there will be some licensing for this software. So can you explain us which type of licensing, demo possibilities, or what you can have actually? Which type of models?
Yeah, so we will have the basic license for basic use. It includes basic explorative tools. It won't include spectral library or the training part. And then we have professional, which includes everything, all the features that are available. We have different kinds of licensing lengths. So there's 1 year license and 3 year license. There's possibility for online licensing or offline licensing. And also demo licenses available.
So there are a lot of possibilities. So basically there is a basic version, there is a pro versions with different level of complexity or different features which are available. There is different timelines. There is if it is based on online or offline. And also for the demo licensing, do you know how long is the demo license to be valid?
30 days.
30 days.
At this time.
And actually it's possible to sign from our website to get like this a demo license to try actually our software. Okay. Is there anything else you would like to add about this new version of the software?
There's one thing that we've also added. Now there's a possibility to update the software. Okay. So if there is a new release in our release servers, the software will tell the user that a new release is available. Okay. And if their license is valid for the new release, then they are able to use that. Download it and install it and use.
So automatic notification and then possibility for the user to download.
Yes.
Oh, that's a great add-on. Talking about the software is nice, but seeing is actually better. So please stay tuned. Now we're going to have actually the demo. And after that, me and Henri, we are going to answer all of your questions. So have a look to all those new features with the demo and then see you in about 20 minutes. This video is a demonstration of the latest improvement of Insight 1.4, which is then going to be released in April. So this is not intended to be a tutorial. We have dedicated material for that. It's just to show the latest improvement. So I'm going to show that to you here. I will highlight some new feature in the user interface. As well in Explore, there are some new things about selections, about pre-processings, and finally about the spectral library that's possible to create and use. So first about the user interface, you can recognize here that there are some eyes that pops up every now and then, like here on the user interface, and it actually relates to the manual. So if I click on that one, you can see that in fact there is a manual which is now included in the software, and you can actually select some subchapter like this, and you will go directly to the relevant area where you need to have the information. So that's a nice feature, and I say you have it here also every now and then, which is just located here to help you. Then about the user interface and the latest improvement. So basically we have here a data set which was acquired with an FX17 with different type of plastics. And I would like to show you that now there are as well for the selection some new features. So if I make, for example, some selection like this, I have the possibility also to scale them. So here I can take a scale, select that one, and then with Control plus and minus, I can choose also manually to have it bigger and smaller. I can do the same for the second one. I will remove those one to show you another feature which is quite interesting. With the magic wand, like this, we can ask to make selection like this to be detected. Also to create more, so to have a count to find more like this one. To create here individual selection, which relate to those region of the image. Here again, you can choose, in fact, to have them smaller and bigger. So here it starts to get more interesting to use the tool I was presenting previously, like this. But what I wanted to show here is like you can select multiple selections like this, and now you can actually merge them into a single one, like you have here. If you want to split this merge selection, you can do it as well here by selecting it and then doing split the selection, and you find again the origin one that we had. Those are nice features like this I wanted to show. So I will remove them, maybe not one by one, but all at once. Remove the selections like this. Also, there is something new in terms of calculator, which is here. Like in the past, the user has a possibility to make his own formula, his own indices, but we also have more preset formula, like the one which are here, dedicated mostly for geology, like you have here, like mineral indices, which are here as well, and sorted some vegetation indices. So that means like if you already capture an image and you want to apply an indices like this to highlight some minerals, to highlight different things, there are some preset formulas which can really help you for this. Of course, I said you can create your own. This is not any problem. Then, to go a bit further with the pre-processing, first we need to make some selection. So I will select one for this type of plastic. So here we have sample made of PE for those 4 ones. We have actually here sample made of ABS, PVC, PS, PA, PP, transparent PC, as well as PET. And you can see here all the spectra which relate to each of the selection. If I click on this button, which is about pre-processing, I have the possibility to add a preprocessor. So for example, here a Savitsky-Golay, so I could add here. We can adjust the parameter as we wish. Then we can choose to actually apply it on the spectra. So now we can see what is the effect on the spectra of this preprocessing. But then we can also choose to see the effect on the image itself. So it highlights how this preprocessor is efficient in sorting the different type of materials that we are having in this image. Also, if I want to highlight the results on the samples only, but not necessarily on the background as well, there is a possibility like this to remove the background and also to adjust the threshold of background removal like this. This threshold applies on the reflectance value. So you have the possibility to do that. Another thing which is actually quite interesting, if I remove that one, is like you can also have the possibility to make a principal component analysis. So first I will remove the results that I'm having here, like this. You can compute a principal component analysis like this on the full data set or on a selection only. So here we can just run it. The results will come in a few seconds. Now we can see the results, and this PCA could actually be saved as a preprocessor. So here's going to be PCA webinar, like this. Then we can save it, like this. We finish. And then if we go back to the preprocessor, like here, we can then load it, PCA webinar, PCA plastic was another one. We can apply it, and then we can see the results on the image like here. Notice that when you have a pre-processed image, like the one we had before with the Savitsky-Golay, and also now with the PCA, you have the possibility to save it like this. Either it will be added under to current dataset, so it means that it will come just here, or you can create also a new dataset. Now, I would like to speak about the results. I would like to speak about the spectral library, because now, as you understood, there is a possibility to create spectral libraries. Remove things here like this. Again, I remove the results so that we can have only the selection. And to create a spectral library, I can go like this to the wizard, and I can create a new spectral library. So here we have the first reference. We can actually change the name. So the first one here, it was PE. We'll select it or change it. Then we had the ABS. The third one was related to the PVC. Then we had the PS. Then PA. Then PP. Sorry, this PP. Then we had the PC. And the last one, it was in fact, again, to select it properly, PET. So then here we can rename it. Then this is the spectral range. Then we can go to the next menu. We can give a name to this library. So which is going to be demo webinar, like this. When the selections are large enough, it's possible also to save a covariance. If you don't, it's the same as saving only like a single pixel. Of course, when you select a single pixel, it's more like an average, which is here over the selection you have made, but still, if you select the covariance, it means that you get actually more dynamic in the library which is saved. There are different formats for the library to be saved. So here it's going to be an NV format, but you have also CSV or NV, ASCII. Output directory, this is me, this is fine. And I would like to add the library to the Explorer. Yes. So now basically we have created a new library, which is here. Creating a library is nice, but you also want to apply it typically to a data set so that you want to recognize different type of material, for instance, in something that you don't know. So here we know this data set. So that was our reference data set. But then we can open another one. Here we will open a data set which is here, for example, plastic mixture, where myself, I know what are the material made of, but I'm not going to say it now. And then we want to apply the library we have made to apply it here to see what is the match. So to do that, we have a tool here, which is match to spectral library. So here you can choose the libraries that you have open here in the Explorer. It is the spectral library which is in Explorer, so this is actually the one called demo webinar. We have two algorithms here, like for the library matching. We have the spectral similarity as well as the maximum likelihood. I will use that one. And then we can choose as well to have a background removal. Oh, I will keep it on. Let's see what happens. And then there is a possibility as well to apply some pre-processing. So let's first do without pre-processing, and then we run the library on the dataset. So we have some recognition is not perfect. Then we can try to improve that. First by doing some background removal. Now the library is focusing, the matching is focusing only on the samples. And then we can also apply here some pre-processing. Typically for plastics, I like to use Savitsky-Golay as well as SNV. So here, and I will put with the Savitsky-Gelley a derivative of the first order. And then we can try, we can run it. So it makes identification actually cleaner. But what is interesting is that we want to know what we have. So we have the light green, which is here. Light green, it seems that it matches with PET. We have the blue one, which is here. It seems to match with PVC. And then we have the orange one, which is here, which seems to match with PE. So here we can actually compare with the spectra. So for example, if we look the spectrum of PVC, so let's go back to the visualization. We'll remove the other ones. So remove PP, PA, ABS, PS, PET. We said we had PC, we did not have PE and PVC. So now we have those, like this. And then we will make some selections. So here we had one material, here we had another one, here we had another one. Like this. I was wondering why we had a lot like this. I want to remove the selections like that. So now it's a bit more clear. So then we have the three selections we have made. And as said, we wanted to compare with what we had. So we said there was probably some PVC. Yes, it matched. There were probably some PE. Yes, it matched as well. And there were also some, what was the last one? Some PET, and it seems to match as well. So here you really have the possibility to create your own library and also to apply it to different data sets. You can do that as well, by the way, in training. So when you want to build a model. I would like to show here the library menu, which is here. So we have demo library, the one we just created, with the possibility again to visualize the spectra one by one, or to have several like this. And then you can actually load this library into the training. So first you need to open a dataset. I will open one. So for example, if I go back to this dataset, I can open it in training. Up, here we go. Then I can load actually the library, which is here, into the training as well. Here it is. And the library is not here. So you can use it as well here on a dataset that you have open in here. Notice that it is a spectra. It is not necessarily a class. For example, you could have like several spectra which could be included in the same class. So you can have, for example, group A of plastics, and then you can put the spectra of PP, PA, and ABS. Group B, it could be, for example, PS, PET, and PC. So here we will make it simple. I will create, in fact, like this, 9 classes. Why 9? I have 8 plastics, and then I will take one for the background because I think about the PC, which was like quite transparent with a low reflectance. So here as a background, I cannot use really like a low threshold anyway. So I will create another one. Class 9 is going to be the background like this, and I will put it in black like this. And then the other one basically is going to be the usual name. So class 1, it's going to be PP. Class 2, it's going to be PA. I just follow the orders that I have here. Then class B, ABS. Then it could be PS. Then PET. Then PC. And here we have so PPC. I think I have forgotten one. Yeah, actually it should be not PC, but it should be here. Let's put it PE. Yes, but I forgot. And then the P is PEC, which is here then OK. And then for each of them, then I attribute the class which is against. Yes, here we are, and then we have the PVC. And finally, I will make also a selection, as I said, for the background, which is here. So you can see actually you can combine selection of your dataset with spectral library like this. And then we can try to make a model to see what happens. So we can just test here before I need to increase the amount of latent variables. We see the classification we will get. Not a perfect one yet, but still something, which is actually quite nicely identified. Then again, we like to apply some pre-processing, like we are used to do. We can use the Savitsky-Golay and the SNV, like this. Savitsky-Golay with a derivative to highlight the peak position. Let's see if it improves. It is actually slightly better, not for everything. We can see that here it's a little bit dirty. On the other hand, I was making selections only here on the middle of the sample, but not on the edge. So we can do that, or actually we can change a bit the pre-processing. I will add derivative min-max norm like this, and I will change actually the order. So let's make this a little bit bigger like this. First, I will apply the Savitsky-Golay just to smooth. Then I will highlight the spectral differences like this with a min-max norm. Then after that, we will derivate with a first order, and then we will do the SNV. And then let's see what we have. Does it improve a little bit? A bit, but not too much. Maybe here I need to make a selection, but anyway, just to show how it works. And then we can open, for example, another data set that we are having here inside demo. Let's take this one, let's open it, or this one, let's open it into the training again. And we can see, if we run a test here, what we get. On this data set again, which is a training one. And then on this one, and here we have nicely made the identification of the different type of plastics. A new feature, actually, which is here quite interesting as well. I would like to show it. When you create like this a model, and then you want to open the full report of this model, you can just open it like this by clicking on it. It opens. You can see that on the image where you have actually applied this, how many pixels have been actually sorted as PP, PA, ABS, or for the different class. Let's put it that way. And here you have it relatively, but you can have it as well as a pixel count. So something quite interesting when you want to know basically how many pixels has been sorted as what, as part of your image like you have in here. So those are the features that I wanted to highlight here in this demo. I hope it gives you a hint of the latest improvement, what you can do. And if you have more questions, please do not hesitate to come back to us. I'm back, and I hope you liked the video, you liked the interview. I think, and I hope it gave you quite a good insight about the new feature like this, about insight, by the way, so insight about insight. So I see that quite many people asked some questions, which is really, really good. So I will do my best to answer those. So as I explained before, unfortunately, Henri got sick, so he's not here going to help me. But I will try to do my best really to answer all of them. So I see we have a bit more than 10. So I will do that. Here we go. So I will take them in order. If you have more questions, please do not hesitate to write more, and then I will answer. Does it work with SpecimIQ files too? Actually, yes. It works also with the data acquired with the SpecimIQ. It's just that because they are acquired sideways, the way they will be displayed is going to be a bit like 90-degree rotated, but you can just put it back to shape like this. So yes, it works. Which part of the software does the data QA/QC? It is actually not part of Insight. The QA/QC, it's part of Lumo. If you are using like Lumo Scanner or Lumo Recorder, there you have the QA/QC. And it is part of this software. So not part of Insight, but it's part of Lumo. And there it checks, for example, that the white reference is really a white reference, the dark reference is really a dark reference, and also if there has been drop frame. But it's not part of Insight. Is that an average spectrum shown for each type of material? So when you make a point selection, of course, you can get only the spectrum for this point. When you make an area selection and you want to get the spectrum out of it, you can choose actually to see only the average, only the median value, or even to see like with the density, how the spectra somehow is distributed over this region. So you have different possibilities like this. If I have a license for a period of 3 years, and there are updates within the license period, will the update be fully covered by the current license? Yes. So if you have like a time license, which is like 1 year or 3 years, the updates are included. If you buy a perpetual license, the update will not be included. Can I use SpecimINSIGHT to analyze any NV files, or is it compatible with image acquire with your MIPE hyperspectral cameras? It is compatible with datasets which are NV compatible, like NV format, saved with the BIL interleaves. So if you save the data in another type of format, it will not be able to open them. But if it is BIL interleaves, I have tried like a dataset from different camera suppliers and it worked. So in that respect, you should be fine. Are there any limitations to using the software offline, accessing the spectral library or the data size to be processed? No, you can use it offline. Online is not a problem. So for example, me, when I use it offline, most of the time, by the way, you mean without internet connection, that's what I understand. So basically, no, there is absolutely no issue for that. You can build your own spectral library, save it wherever you want, and so on, that's not a problem. About the data size to be processed, here it depends basically on the RAM of your computer, because of course you can choose which backhand you want to use with the software. Either it is GPU based and then it depends on the memory available in your graphical card. But then if it is CPU based, it depends on your RAM memory. So yes, you will have a limit, but it's not depending on the software as such. Do you have any tool to reduce specular reflection artifacts in the image? Do you mean like, for instance, stray light or things like this? So if it is the case, no, we don't have such a tools to remove the stray light. If you mean about the specular component of the reflectance, if you want to have only the diffuse part, no, we don't have such a tool either. Okay, so here I have issue with the software interface, but then I will see the image like here. How can I generate a model to detect foreign substances that have not been labeled when I want to inspect them in the food company domain? That is, for example, since various bugs and foreign substances in the cabbage cannot be labeled daily, how can I detect them as a foreign substance other than cabbage? But here, I would say you have two approaches. If you work offline, you can simply make, for example, a principal component analysis. When you are making a principal component analysis, this unsupervised method of classifier will be able to detect if you have an object which is different from the others without knowing necessarily what it is, as long as the spectra is different. So here you can make the PCA, And then it will detect automatically if you have like, how can I say, like spectrally different objects. That's one way. Then if you want to work online, sorry, like meaning in real time, with our insight, you have the possibility to teach what is a good object. So for example, what is a cabbage? And you can say like within this, a certain level of tolerance, this is cabbage. But everything which is outside this level of tolerance is not cabbage, it is a contaminant. And this is what we call like unclassified. So there is a possibility to define like this what is good with an index of tolerance or like a threshold, and then everything which is out of it then is a contaminant. So actually we made this type of function especially for the case you describe here, not necessarily for cabbage, but it could be whatever. Then I will take the next question. Are there any other analysis methods than PCA available? Yes, so in this software you have the possibility to make model with PLS, PLSDA, and we also have the calculator. So here you can make like band ratio. You can choose actually to combine band together. So those are the algorithms which are available. Also, if you want to deal with color, also in the calculator you have the possibility to convert visible spectra into color coordinates. So those are the algorithms which are the date of today available. Be aware that we are working on adding more and more algorithms. But at the date of today, this is what we have. Keep in mind, by the way, we have as well quite a lot of pre-processing. So it's not really an algorithm, but I would say it improves as well the classification. Can it do regression? Yes, it has a PLS, and then it can do multiple regression at once. This new version allows to export all spectra of selection. No, you can export only the average spectrum of a selection. You don't have the possibility to export every individual spectrum. Is it required to have other software from Specim to perform all the data manipulation and analysis demonstrated in the demo? No, in this demo I was using only Insight. I did not use anything else. The only time that I may use another software, it is for instance when you remember I made a webinar about how to acquire data on the field. And when you want to convert radiance data into reflectance when you have the white reference which is covering only part of the field of view. So then here I had to use NV because we have an add-on for NV and so on. But except of that, no, here in this demo I was using only Insight. Which classifier algorithm are used? PLS, PLSDA. I forgot we have also the spectral angle mapper, the PCA, and then the calculator. Those are the algorithms which are used, but if you think about what could be used for real-time data analysis, it is PLS and PLSDA. So next question, I guess, is coming. Yes, price of the software. So here, I would say that's a really interesting question, but it depends, by the way, on the licensing that you choose. We have different options. We have the Pro version, which include everything. We have the basic version, which does not include every functionalities. We have 1 year, 3 years, and perpetual. So here, basically, it depends on which package you want to purchase. But of course, I'm not going to answer here because we have competitions here as well. Hello. So if you want to have more information about that, please send an email at info@specim.com, and then we will come back to you. Does the software support importing standard spectral curve in NV format? So for instance, if you make a spectral library which is saved in the NV format, yes, you can import it. You can also import like library which are saved in the ASCII format. We have application in agriculture, like detecting aflatoxin in peanuts, for example. Can your application and hyperspectral camera can be integrated for this application? Yes, well, to the best of my memory, aflatoxin in peanuts can be detected with fluorescence. So basically, you need to have a UV light, which is something at 350, 365 nanometers, and then it will excite the contaminant, and then it will start to emit in the visible. So for instance, you could use an FX10 camera, which is between 400 and 1000 nanometers. Then the emission, the fluorescence basically will be seen over there. And then yes, our software can just see it because then it's part of the visible spectra. One thing which is interesting here, you are working now in emission because fluorescence is actually a type of emission. So for research purpose, I will actually recommend to use a camera which is radiometrically calibrated so that you can work into radians. But then for real-time processing, this step might be a bit too much time consuming and you don't want to do research, you won't detect if you have a spectrum at a certain place or not. So then you may just work like this with the raw data. But be aware that then the transfer from one camera to another one might be more tricky. But here, yes, our software and our camera could be used for that. Can labels be imported from labeling tools, for example, Darwin V7? To be honest, I do not know what is Darwin V7, so I'm not sure like I can really answer this question, but can label be imported from labeling tool? I don't think so, no. Are there any difference between working online or offline? Limitation to function slow elaboration? I think I had a question like this already before. No, if you want to work like with or without internet connection, it doesn't matter. It depends on your licensing. Then if you purchase like online or offline version, but I mean, in terms of what is available for the software features, no, it doesn't matter. Can inside object separation be recognized? In other words, if a damaged strawberry and a normal one overlap, is there any way to see each object separately? No, we don't have object recognition. That's something we are working on, but we don't have like this. So the classification we have in Insight is done pixel per pixels. So object recognition, averaging or selection, segmentation is not part of the software yet. Is there a possibility of masking the data manually instead of PCA or thresholding? With thresholding, with PCA and thresholding you can do it. Masking the data, well, you can also select what is the background by putting a thresholding. No, we don't. Well, okay, that's what we have, but otherwise, no, we don't have any special masking function. If an algorithm or pre-processing tool is not available, is there a possibility to export the data to program that ourselves? If you do not find everything you need in Insight, be aware that the data, they are saved in a format which is not proprietary from Specim. So we have a lot of customers which are actually acquiring the data with Lumo, and then they actually open them with Python, with MATLAB and things like this. So here, if you want to import the data into another software where you can find actually the algorithm of your choice, you can do that. Where can we access the previous webinar? So here, actually, I think Harry sent you the link. It is on our website, libraries and webinars. If you apply the model made through Insight within the Speaking Cube, please let me know how I can develop a module that can predict in real time. Well, the whole idea is that actually Insight is part of this platform Specim one as well. So when we make a model with Insight, to be applied for real time, then we want it to be used with the cube. So this is the idea. What version of curve firmware are recommended for Insight 1.4? Here I have to say I do not know this answer just right away. I need to consult with the software team. I don't have it out of my head just here. So we will come back to you or drop an email at info@specim.com. Do we have any more questions? We still have a bit of time. So I will wait still a little bit. But what I can say as well is like, from my experience, when I'm using this software, moving from 1.3 to 1.4, I think the spectral library is something which is really, really neat, really something interesting to look. And I think it enables as well a lot of application, and also it will help in terms of like making test feasibility studies for you. So I really think that it's the step forward. Is this webinar recorded? I'm late, and how can I get an access if yes? Yes, this webinar is recorded, and it will be on our website under like specim.com library webinar. And if you are registered, as far as I know, you will get as well a link to the record, to the video. If you need to send signals to the facility according to the equipment classification results in the cube, I need to read it again. If you need to send signals to the facility according to the equipment classification results in the cube. So I understand if you have a sorting machine and you need to control some actioners, let me know how it can be handled. So basically you make a model with Insight, and once you have made a model, you can convert it into an application, and this application can then be loaded into the cube. Then, when the camera is connected to the cube and the application is on, it will convert in real time the spectra into classes. It can have an ID number, it could have a color, depending if it is A, B, C, or D, or if it has even like a regression value. The output of the cube is following two protocols. It is a GigiVision protocol, or it is a UDP protocol. And then this can then be integrated into industrial environment, like for example those of Beckhoff, for example, or there are some other ones, or like with Halcon. And then here you can then trigger different type of actioner. This is the way it can be used. Do we still have, what is the pricing? I already answered, so please drop an email at info@specim.com. Can AFX10 or AFX17 data also be analyzed in Insight? The data can be seen, that's not a problem, but everything about georeferencing, like for example what you can do with CaliGeo Pro, or if you want to apply atmospheric correction, that cannot be done in Insight. Insight is more dedicated for, I would say, research or like industrial data, not really dedicated for airborne data. But as said, so if you have already a radiance data, georectified and things like this, yes, you can open those. Do you have example in agriculture? Yes, actually. If you go to our website, specim.com, there you can go actually to some of the success stories. And here you will see actually there are like some usability, some success cases where our camera has been used, for example, for phenotyping, for vertical farming. And as well, we have quite a lot of customers using our camera for precision agriculture. So as you know, we have cameras which are dedicated for field work. So for example, the IQ, but also the FX10, FX17, which could be mounted on a rotary scanner. And actually here, I invite you to look at the webinar we made about how to use a camera on the field. And we also have the airborne camera. So for example, the AFX, which is very like useful for this type of application. Then the next question. I go to the top, sorry. Here we go. Can you show the process for getting to reflectance using the software? I see there is tabs in the top with white ref, dark ref, raw, dark, subtracted. So when you use the software, in the first window, there is something which is called the browser. When you right click on a data set, you can add basically the dark reference if it is missing, the white reference if it is missing, and then you have the possibility as well to compute the reflectance data based on those. In order to be successful, you need to have, of course, the white reference, which is covering the full field of view. Then there is a possibility to do like this. Also, if you use our acquisition software, Lumo, it records the raw data, the dark and the white reference. And then we have a plugins as well, which allow you to also get the reflectance data. Is it possible to use hyperspectral image from another camera? As such, yes, because like at Specim, when we save our data, it's not a proprietary format. So that means this is like just a well-known format, which is a NV format with BIL interleaves. So if you have actually data which has been acquired with the same format, then it could be open. We know that there are some other formats available for saving hyperspectral data. So if it's not matching with the NV format BIL interleaves, then it will not work. Can we import external spectral signature? Yes, you can do that, especially for the spectral library. It is compatible with the spectral library with the NV format again, but also with the ASCII ones. Is this software also works for multispectral imaging collected from crops canopy? Well, basically, how to define a hyperspectral image from a multispectral one. Isn't it the amount of band somehow? So yes, it's just a matter of having a certain amount of band. And sometimes I've been making simulation as well, like instead of recording the 224 bands, for example, of the FX17, just to do binning simply by 2, 4, and 8, and then you get less band, and you can still open the data. So yes, it will work as well for multispectral data, but they need to be saved in a format compatible with InSight. But I would like to finish, by the way, on the same question. Collected from crop canopy, be aware that our software does not understand what is georeference data. This is not a software which has been designed mostly for like remote sensing application. So georeferencing is not something which is understood by the software. The next question. So how does the spectral libraries differ from the model that we train? Why would I want to use one versus the others? Well, the spectral libraries, it could be really useful. For example, if you have, like in this case, you have a lot of plastics. You can make a spectral libraries, for example, 20 or 30 type of plastics. And then when you want to make a model, basically you can choose the plastics you have depending on the library. You can use that as well in geological application. So for example, when you want to identify different type of minerals that you have in a core, for example, you do not necessarily want to run a model because the model performs well if you have maybe 5, 6, 7 classes, and then it doesn't perform well anymore. But then you can run different spectral libraries depending on the geology, what you are having. So it differs a bit. It's quite similar as well. But when you have a model also, when you make your selection, you try to make selection which encompass as much a diversity of your object that you want to measure. So if I explain more, if I want to separate almond from the shell, you want to make a spectrum of the shell, but not a single point. You want to have like a lot of spectra somehow to really to be able to model to take into account all the diversity of what a shell looks like, spectrally speaking. A spectral library doesn't necessarily take that into account. In our case, we can because we can save the variance, but it's not always the case. Statistically speaking, does it include multivariate analyze or machine learning techniques? The algorithm we have now implemented in Insight, we have the spectral angle mapper, we have the principal component analysis, we have as well the PLS and the PLSDA. So it doesn't have, what we call machine learning, a little bit like neural network, but I have to say that our software team is still working to always add more and more algorithm within the software to be able to tackle different type of applications. So at the date of today, we don't have a lot of different type of algorithm like those, like the one you mentioned, for example. But I have to say, like, it will come in the future. Then the next question. How were the mineralogical indices developed? Oh, that is more like from different type, like publication. Mineralogy, geology has been working like is a field, sorry, where a lot of scientists has been working for many, many, many years with the mining industry and looking at the spectroscopy and the spectral features, the spectral signature, different type of indices has been developed. So it hasn't been developed by Specim. It is something which is like you can find in the library, for example, in the literature. So this is how it is. Can the system evaluate live image, like steel plate on a roll line moving at 60 meter per minute, I guess? So, well, the software itself is here to build a model. So it's made like for offline. It's not really for online. But once you have your model, you can convert it into an application, and the application can then be loaded into the cube. Because remember that Insight is actually part of the Specim one. So when you have the cube, which is a GPU-based platform, then you have the model, which the application which is there, which is then running, and when the camera is connected, you don't get at the output of the cube the spectral data, but you get the model, you get the classification. And this is done in real time. So Insight alone, no, is not here. And it's not designed to process in real time, but the application loaded into the cube, yes. And then a plate roll, a steel plate on a roll line moving at 60 meter per minute, yeah, it just depends on the resolution you want to get, the camera you are using, what is the frame rate, what is the integration time. But yes, actually, our cameras, they have been used with the cube over like, for example, conveyor belt to sort different type of plastics, 1 or 2 meters per second. This is not a problem. How to translate the offline testing to inline system? Well, it is basically, I think I just answered before. I was explaining you need to have the cube. Once you have made your application, you load it into the cube and then it's done in real time. Can it be used as an API plugin? So basically, um, we provide the cube basically with a protocol to communicate like different type of machinery behind. So here we have the UDP and the GigaVision protocol. But if you are talking here about Insight only, no, it's a closed software. So here you are making your application and your model, and you cannot put different type of model like you would like to have a bridge to put it there. Why PCA is considered as a pre-processing method? Is it a mandatory or advised at least step before machine learning application? That's a good question. Myself, I do not consider it either as a pre-processing method. I consider it as well more like an analytical method. And I like to look at it, especially to look at the loading, to see which wavelengths are more important than the others, because this is the essence of the PCA, like this, to combine the bands. So I would use it to check, yes, which bands are the most relevant one to sort different things from each other. And then, with the FX camera, you have the possibility not to look at the full spectral range, but you can select only some bands. You can create like multiple region of interest, spectrally speaking. So I would use it more for that, to correlate in a way that, yes, okay, those are the bands of interest. So I think it's not mandatory, but it's a good tool to check how to separate things from each other. Do you have example for textile and paper? Textiles, yes. If you go to our website again, so there is a possibility to find like success stories or different application studies on our website where we can sort different type of textiles. So cotton, polyester, different type of blends, and there are more than that. So yes, for paper, I'm not sure what you mean. If you want to sort cardboard from paper, or if you have like coated paper, that's we don't have it necessarily on our website, but this is something where we have experience as well. How well can it handle an industrial environment? No air conditioning and varying ambient light. So if you think about the camera, hyperspectral imaging measures the reflected light compared to the incoming one. So basically, you need to make your system somehow uh, resistant or like like which can take into account you may have like a variation of ambient light. So you need to have casing around to be sure that you don't have like variation of the ambient light. That's the thing. You need to make a casing around. There are some possibility. We have customers doing that. Also, for the air conditioning, there are some casings that you can put around the camera, which could be temperature stabilized. Actually, there are some available. If you go to our website, there are some from Autovimation, to give an example, and those could be air conditioned. Our camera work between +5 and +40 degrees, but that's true that for some application, it needs to be well controlled, especially, for black plastic, for FX50, for example. So yes, you need to take those things into account, but be aware that, for example, if you think about a variation of incoming light, of ambient light, you could take that into account in terms of making pre-processing, like when you make derivative, you kill somehow an offset in the illumination. So that's one way to do. But really, you have to make your system like this more cased so that it is like resistant to ambient light variation. What are the different purposes for using Specim IQ Studio and Specim Insight? Okay, so those are two different software. So IQ Studio is actually supplied with the IQ camera. And when you use the IQ camera, you can also build an application that you can load inside the IQ camera, and then you can already get some classification out of the IQ camera. The IQ camera can get an application which is made only by IQ Studio. And in IQ Studio, you have only the spectral angle mapper as an algorithm. With SpecimINSIGHT, you can also work offline, so you can get data which are not necessarily from IQ, but from FX camera. And then you can make a model with more possibility for algorithm, not only spectral angle mapper, that you can then load into the queue. When you make an application in Insight, you cannot load it into the IQ camera. I forgot one question apparently. Okay. Is it possible to analyze very small samples such as microplastic? Yes. Actually, this is an application that we are getting more and more requests about, and we have lenses for that. So for instance, for the FX17 and the Sphere camera, we have what we call the OLS macro. And then with the FX17, you get a pixel size, which is about 19 or 20 micron. With the Sphere camera, it's about 24 micron. With the FX10, which is between 400 and 1000 nanometers, we also have a macro lens. And then you can get a pixel size, which is about 10.4 micrometers. So yes, we have possibilities, and we have more and more actually like requests about that. Is radiometric, atmospheric, geometric correction possible within this software? No. Radiometric calibration, yes. Atmospheric and geometric, no. For this, actually, we have Caligeo Pro, which is our software dedicated for this type of things, which is like actually an add-on. It needs to have a roots on NV, and then you can convert raw data into georeference radiance data. However, it doesn't do atmospheric correction. For this, you need to use another software. But yes, radiometric and geometric could be done in Caligeo Pro. I am aware of the UHAS mineral spectral library, but are there any other prominent publicly available library for other applications that you can mention. Agriculture and vegetation are areas that I'm most interested in. Okay, the USGS is a very famous one. I know that in NV there are some other ones which are like dedicated for vegetation. I don't have the name just now, but I know there are at least 2 or 3 which are available as well, coming from the United States and from UK, if I recall well. So here we can come back to you or drop us an email at info@specim.com, and then we can give you those references. Can you append or add new spectra to a spectral library? Yes. In that case, with our software, you can open an existing spectral library and then you can add a new spectrum. And you can also remove spectra to create a new one. We have a UV-Vis detector attached to our chromatographic separation system. Do you know if I can export this type of measurement into InSight for pre-processing, library creation, etc.? If it is not a hyperspectral camera, if it is not providing hyperspectral data in the same fashion as we produce hyperspectral data, with like spatial dimension, uh, with like spectra as we understand it, which are saved in the NV data type with BIL interleaves, it will not work. Do you plan to implement independent component analysis in the future? We are looking for different type of things. So I know that neural network is one that we are strongly considering. There might be some other ones. So this one maybe, but I'm not, part of the software team. So I can hear maybe they discuss it, but I'm not aware at least of that one. Can you further elaborate on how models can be exported and embedded in software application? About how? I need to read it again. Can you further elaborate how models can be exported and embedded in software applications? I'm not sure to fully understand what you mean here, but how a model can be exported. So basically with Insight, we just save the model, you right click and you publish it as an application. Then this application can then be loaded into the queue because it has a software to be able to receive this application and to run it in real time. But if you want to export this model or the related application into something else, then there is no possibilities. Is calculation of first and second derivative a mandatory step in pre-processing, or is it highly recommended? It depends on the application. I would say like when you want to sort plastic, textiles, or even the food industry, it is quite recommended, especially the first one, because as I say, if you have a round object, it is the same chemistry. So here you have a certain spectral signature. Here you have the same one, but because it's a bit more shadow, you have a little bit of offset in between. So it's spectral. Let's say that the spectral here is more intense, is the same as here with an offset. So when you do the derivative, you highlight where you have the peaks on your spectral signature, but you also remove the offset because the derivative of the constant is equal to 0. So in some application, it is highly, highly recommended. But for some other ones, it is not recommended. So for example, if you deal about vegetation analysis and you use a camera between 400 and 1000 nanometers, not so many people use derivative in there. If you want to deal with color analysis, you do not necessarily want to use a derivative as well. So it depends on the applications that you are working on. What wavelength range does the software operate under? It can do everything. So basically, we are making a speaking camera which covers a full spectral range between 400 and 12,000 nanometers. So for the software, it doesn't really matter. A wavelength is just a number. Can you explain a bit more about the classification algorithm? Will we be able to implement import a classification model? So here, the models that we are using, that we are the algorithm, sorry, we are basing our model on, it is a partial least square, or it is the partial least square discriminant analysis, PLS, PLSDA. So this is the one we have now. And these are the ones that, yes, those are the one now. We choose those one because they are quick. And the idea was that to have inside part of the Specim one to make real-time data processing. So in order to be fast in terms of latency, you needed to have an algorithm which is able to run fast. So that's why we chose actually those one. So will you be able to import a classification model as the date of today? No. Inside the closed platform that you make your model, then you convert into an app that you can then put into the cube. How many model libraries are available? What type of material I covered? Is it likely to start with a library model and get a 80% fit and then tweak from there for a specific application? Well, the software, first of all, is not provided with any library. So you can import a library that you can get from somewhere else. You can build your own library, but I think there is no real limit about the amount of library. I think to the best of my memory, you can load more than 100. Uh, but yes, we don't provide with one. So then, is it likely to start with a library model and get 80% fit and then tweak? You can do that. You can work with library. You can work without library. It's up to you. Until now, we were working without library because we did not have it in our software. But I have to say that was a little bit tricky because sometimes, you had to make a lot of data set to acquire them, to make the selection, and then to make your model based on that. Now you have the possibility to have some training data set where you can build the library, you can store it somewhere, and then you can make your model as well after. But then I agree with you. You can use this library as a base. It could be like a good base to start basically your modeling. And then you can acquire image which actually, uh, how can I say, which contain more of the diversity of what you want to sort than the library itself. And then you can tweak and improve like this your model. Can the software import measurement from a point spectrometer, which is not a cube in a cube format? No. Do you have a list of approved US integrator? We have integrator in the United States, but in this webinar, we have also the competition, which is looking at us. So I'm not going to give openly like this a list of US integrator. So I advise you actually to send an email to us, info@specim.com, and then we can help you to find the right integrator for you. Is it possible to update the calibration, the illuminators via a software program? 3 objects in a row have 3 different hyperspectral curves in column instead are, okay, so now I need to read it again, sorry. Is it possible to update the calibration, the illuminator? So here you mean maybe the white reference. So yes, it's possible to update it and to change it. Via a software program. 3 objects in a row have 3 different hyperspectral curves in column instead are similar. Anyway, 2 consecutive scans provide different hyperspectral results. Maybe this depends on temperature. Well, this is true that the temperature in some application has an impact, especially on the dark noise of the detector and why not on the samples. But I have to say our measurements are most of the time quite repetitive. So in that respect, if you measure the same object 3 or 4 times, you should get 3 or 4 times the same spectra. I hope I answered the question. I'm not too sure here. In our lab scanner with the FXN camera, the temperature reached 68 degrees. Okay. The camera, yeah, okay. Some samples cannot stand on the platform for a long time due to the change of the structure. Well, if you leave, you keep in mind that we have halogen. So if you have your sample too long under the halogen, this is true that at some point it will get warm. So typically what I'm used to do when I make measurement, and especially if the temperature may change the structure. I put all the parameters of the lab scanner before without putting anything. And then when I need to make the measurement, I just put a sample, measuring quick, and then I take it away. How can we overcome this problem? I think this is the same as I just answered before. After selecting different objects, if the selected area are very similar and we want to paint them differently, what is the best algorithm order to follow? White sunflower seeds and a white cigarette are good examples. The important detail is that the area to be selected is not very large. That is, there is a little data, the objects are small. I think there is no question here, actually, or is there? After selecting different objects, if the selected area are very similar and we want to paint them differently, what is the best algorithm order to follow? I think when you paint or you make selected arrays, like when you have an object which is similar, so you don't need to have a large area because you gather spectra which are basically the same that you want to put in your model. So there is redundancy which is not necessarily. I think this is what you mean. So here I agree, you can make small area. As long as your area are representative of your object, then it is fine. Okay, so here it was not a question. Thank you, Michelle, for answering this question. Okay, and then you mentioned several times cube. Are you referring to the general data format of hyperspectral data, which I understand a hyperspectral cube, or you mean a certain platform? Well, okay, there are two things. The cube, this is actually the platform, which is actually, it looks like a cube, it looks like a shoebox, which is actually here. So you have the possibility, basically, it's a cube, it's a platform. So this is a platform with a GPU. So this is what I refer to. So the hyperspectral cube, this is something else, this is a data set. But the cube, no, it is actually part of the Specim one. This is a GPU-based platform. It looks like a shoebox. Okay, so I still wait maybe 10 seconds. Nice question again. I'm looking for questions. Okay, I'm interested in trying the software for our dataset of geological data. How can I get the software on a trial basis? Do you guys have some training material? Yes, so basically after the 2nd of April, when the new version of Insight will be released, there will be like trial version, which is going to be for 30 days. And then you will have the possibility to try and to see if the software is actually, sorry, good for you or not. Training material, yes, we have some video, we have the manual. And I have to say, this is a software which is pretty easy to handle. So yeah, so if you want to try, just drop an email at info@specim.com and then we will come back to you with a trial when it's going to be available. Can I import spectra data from any years and predict? NIR spectroscopy, I understand. And if it is a point spectrometer, no. Well, actually, you can create, if you get spectral library from that, as I say, the library could be imported as ASCII format. But if you mean just directly the data from your point spectrometers, no. Okay, maybe one last question. If not, then Harry is making me a sign that I may have another one. Yes, here, actually two. So a CSV file can be imported. ASCII format, yes. And then the one just before. You guys recommend a certain workflow for pre-processing before classification. Is there a default pre-processing pipeline? But with the experience, you know that some preprocessors are better than some others. I think I answered to a question like this before. I have to say for plastic, I like to use a Savitsky-Golay with the SNV, sometimes Savitsky-Golay with the first derivative. I like to do as well sometimes a Savitsky-Golay just as a smoothing. Then I use a min-max norm to enhance the spectra. And after that, I use a first order derivative to highlight where the peaks are located. And then finally, I can use SNV then to how can I say to encompass like the variance and the average, the spectra, like if you have more shadow area. But no, I don't really have like a specific workflow like this. This is not a question for SpecimINSIGHT. We have FX10, FX17 cameras. We are using lab scanner, okay? When we take an image of a sample, we often get a dropout in the image of the sample. As a result, the data comes out weird. The image comes out broken. Is this a camera problem? No, it's not a camera problem. It is more like a computer problem. Either you have, I don't know if it is like a Gigi camera you have or camera link. If it is Gigi, it could be actually your Ethernet card, which is not fast enough. Or it is actually if you save the data on a single hard disk. If you have a computer with a single hard disk, we always recommend to have a second one SSD dedicated to the data. If you don't have that, you may get actually drop frame. So that's the thing. It's not a camera issue. It's more like a computer issue. Thank you very much for the helpful webinar and Q&A question. Is the demo video somewhere available in YouTube? Yes, but if you go to our website, actually there is library and webinar. There you can find all the webinars that we have made. So it is available on our website as well. Okay. So what is the software? Sorry. And then it's going to be, I think, my last question. What is the software license cost? Well, as I say, we have the competition here looking at us, and I say hello to them. It's not a problem. But I cannot answer this question here just like this openly. So of course, there is a cost, but then info@specim.com, and we will come back to you. As I said, that was the last one. Thank you very much for all of you for attending this webinar. As I said, I'm sorry that I was alone tonight. Normally, Henri should have been here as the head of our software team, but he got sick yesterday. So, and today as well then. So thank you, and I wish you to have a nice day, evening, wherever you are located. And if you have any question, please do not hesitate, info@specim.com. Bye-bye.